this video, we'll discuss responsive imaging and how Adobe Dynamic Media Classic can help to optimize the quality and performance of user experiences by supporting responsive website design. This is a typical example of a product listing page. It is designed for a web browser running on a laptop or desktop computer. But what happens when we resize the browser window or view this page on a mobile device or a tablet? Clearly, the viewing experience is different on those devices due to the relatively smaller screens. To provide the best user experiences, designers and developers use a term called responsive design to describe websites that are built to modify their design and layout according to the characteristics of the environment they are being viewed in. Observe the images on this slide. The web page on the left is quite different than the same page viewed in a resized browser window. Likewise, it would look different on a phone or tablet. The images have been resized, the layout has changed, and even the navigation and menus have been restructured. The goal of responsive design is to provide a great user experience regardless of the device the user is using. This creates a challenge for designers and developers. Web pages must incorporate intelligence, which allows them to automatically adapt according to the device and size of the window that is being displayed. Adobe Dynamic Media Classic provides a responsive imaging library to help developers and designers address the challenge of requesting the right-sized images according to the demands of the design. When responsive design is used, the same image might be needed at various sizes according to the device or size of the browser window. The image may be needed at a larger or smaller size. We want to be sure that we request images at their optimal size and quality according to the requirements of the design. Typically, special code is used in the web page to determine the context in which it is being viewed. For example, the browser type, the device, and the size of the window can be determined dynamically. But reacting to this can be challenging and burdensome, especially in regard to modifying image requests. This is where the Adobe Dynamic Media Responsive Imaging Library can help. To use the library, developers can add some special commands to their code to include and take advantage of the library, which will make the job of optimizing image requests much easier. Basically, the library will detect when the size of the browser window changes and handle affected images automatically at the sizes specified. The basic steps involve creating image presets without width, height, or scale specifications. The library will do this for you. Then you must add the library to your web pages. You will then need to set up the images in your web pages to use the library. Finally, you will need to call the responsive image library for each image you want to handle. Let's see how we can create a sample HTML file to demonstrate the use of the responsive image library. The first thing we have done is to create some CSS in the head section of the HTML file. We will use it to indicate that the container for our images should fill the full width of our browser window as specified by the row class. Each image will use 50% of the browser width as specified by the column class. Lastly, we have defined a class called FluidImage. It will be used to specify that the image should fill the full width of the column. This script code, highlighted in red, is used to add the responsive image library to your web page. It is essential that you add this code in order for the responsive imaging library to work. You will change the source path of the tag to correspond to your own environment. We must identify the image we wish to manage with the responsive imaging library. Here we have identified the responsive image by giving it an ID named responsive image. This script code is used to configure your image to be managed by the responsive image library. In the script element, we've called a JavaScript function which takes as its argument the ID of the image to be handled. We've supplied ID responsive image to the function, which is how we've identified our image. The image will be handled by the responsive image library. Now we must define some other important attributes of this image. The data source attribute specifies the URL of our dynamic media image. Notice we have also added an image preset to our image called by Sharp. The preset defines sharpening but does not indicate width, height, or scale, as these will be handled by the responsive image library. We set the source attribute to a transparent GIF file, which is encoded directly in this string. This is just an implementation detail that allows the placeholder image to load quickly before the real image is loaded by dynamic media. Finally, we assign the breakpoints. These are important as they indicate the widths of the images to be requested. They will automatically be selected based on the width of the browser window. So for example, if the browser window is 425 or less pixels wide, it will request an image with width of 425 pixels. As the width of the browser increases, the next highest image width will be selected. So if the browser window were 500 pixels wide, it would request the image with a width of 768, and so on. Any additional image downsampling or scaling will be performed by the browser as needed. The breakpoints indicated will depend on the design of your web pages and devices you will support. We have also set the image class to Fluid Image, the class we have defined to make the image automatically scale to the full width of its container. Finally, we have added another image which we will use for comparison. It is not managed by the responsive image library and has been specified with a fixed width of 400 pixels. Since the image is fluid, it will be free to grow smaller or larger in width than 400 pixels. The browser will take care of scaling the image, but as we will see, the quality will be affected. Now let's test our page. First, let's refresh the browser. To monitor what is happening and to demonstrate how responsive imaging is working, I have opened the browser debugger, which you can see at the bottom of the page in gray. I'm looking at the image requests being made for our page and filtering them so we see requests for the black hat photograph only. The image on the left has been initiated and will be managed from the responsive image library. We will expect to see more requests from the responsive image library as we widen the browser window. The image on the right has been initiated from our web page. It is not managed by the responsive image library. It is just a normal Dynamic Media Classic image request. As we expect, additional image requests are initiated as we increase the width of the browser window. The responsive image library has detected the change and made new requests according to the breakpoints we have specified. Note how the quality of our normal image on the right degrades as it is scaled. That is because it is not responsive. The pixel dimensions of the image are too small to provide good quality as the image is scaled up. The responsive image on the left remains sharp because the responsive image library is requesting new images at the required dimensions. Here we can clearly see a benefit of using the responsive image library. You might notice the width values are twice the value that we specified. This is because the responsive image library has automatically determined that the web page is running on a high-resolution display and has automatically doubled the pixel dimensions to get the best quality image. This detection feature is another benefit of using the responsive image library. The responsive image library helps developers to provide high-quality responsive images at the right size for our browser automatically, improves performance, and simplifies the job of developers building responsive websites.